Hey, how's it going in this video? I'm going to be talking about six-axis robot and what it is. Six-axis robot is often referred to as 6 DOF, degrees of freedom. Robot this type of robotic system with 6 different axes of movement or rotations. These axes allow the robot to move and position itself in three-dimensional space with a high degree of flexibility and precision. The six-axis typically corresponds to the following motions. I have dealt with a lot of robots myself, and I work with them. I really would like to work with six-axis robots, perhaps in the future in overall manufacturing. But it might be just not necessarily limited just to manufacturing, but overall. And yes, they can work very fast and they can do a lot of things. And usually, if you would touch it, there's a lot of problems that would happen down the line. But overall, yeah, I believe there's a lot of potential, and perhaps some of the problems that I had personally working with those robots in the past, perhaps that could be overcome in the future. Looking from that, but from that point of view, but overall, so there are 6 levels of robot, and each level has a motor which potentially gives another freedom for robot to move additionally. Overall, base rotation. This axis allows robot to rotate horizontally at its base. Next rotation, shoulder rotation. This second axis enables robot upper arm to move and down, move up and down, usually a vertical plane. Elbow rotation. This axis controls the rotation of robot's forearm and allows it bend and straighten. Wrist pitch. This allows the robot wrist to tilt up and down. Wrist roll. X5 controls the rotation of the robot's wrist, enabling it to rotate to its end-effector, such as gripper or tool, round in axis. Wrist 6. This final axis allows the robot's wrist to twist and rotate side by side. Overall, there's 6 points of rotation. Some of the robots can have 5, some of them can have 7. But usually, for a lot of robots, people are looking for 6 axis. That's that sweet spot. But overall, I have met with some people who do offer different types of robots. Some of them would offer glasses and would give you joysticks that you can rotate that robot yourself. But that might be too complex overall to begin with. With these 6 degrees of freedom, a 6-axis robot can perform complex tasks that require precision, positioning, and orientation in 3-dimensional space. These robots are commonly used in industries such as manufacturing, automotive, aerospace, and healthcare for tasks like welding, painting, assembly, and material handling. This ability to move in multiple axes makes them highly versatile and adaptable to various applications, as well as they can perform different tasks for very long periods of time. That would be 24 hours. They can work for 24 hours, 7 days a week with no more or less issues. There are some issues that can happen to the line if you have one of those robots working there. It would be depending on the task whether the robot might be performing. It might be slight 1 centimeter off. Oh, it can cause a lot of issues, but either way, there's potential sensors that can catch that. But overall, more or less, it's depending on the speed on which a robot is operating and for periods of time, it might require just overseeing by operator. Overall history of six-axis robot arm. The development of six-axis industrial robot can be attributed to the world of Victor Shaman. I'm not entirely sure if that's true. I have done some research before, and I believe there were different sources saying different names, but either way, an American engineer and robotics in 1969. Shaman designed and built the Stanford arm, also known as Stanford manipulator, which is considered one of the earliest examples of six-axis robotic arms. There perhaps groups of people developed similar prototypes at the time. Stanford arm was a groundbreaking development because it introduced the concept of robotic with 6 degrees of freedom. It had 6 joints, each of which could move independently, providing it with a high degree of flexibility and precision in 3-dimensional space. The 6 axes of movement allow the robot to position its end effector, usually a grip or tool, which you will need to replace occasionally, in various orientations and reach points that were previously challenging for robots with fewer degrees of freedom. So if that would be perhaps 2 degrees of freedom, 4 degrees of freedom, I think to most areas that you would find those robotic arms, most of them would have 6 degrees of freedom. Overall, key features of achievements of Stanford's arm were high precision. The Stanford's arm was designed for a high precision task, making it suitable for applications in research and industrial settings where accuracy and flexibility were crucial. Early research and development statements creation served as a platform for researchers and developers in robotics and automation. It laid the foundation for advancements in robotic control and motion planning. Industrial applications were, while the Stanford arm was primarily a research tool, its concepts and principles influenced the development of industrial 6-axis robots that follow it, such as those used in manufacturing for tasks like welding, painting, and assembly. Academic impact: the Stanford's arm availability for research purposes in academic institutions controlled to the growth of the field of robotics and inspired further innovations. Influence on subsequent robotic designs. The concept of a 6-axis robotic arm with independent joints control became a standard in industrial and research of robotics, leading to the development of various robotic arms with similar capabilities. Some of the use cases would be manufacturing and assembly. Some of the tasks would be welding, overall assembly of different parts, material handling, pelletizing, packaging, painting and coating, automotive painting, aerospace and industrial coating, machine tending, quality inspection, material removal, material testing, aerospace manufacturing, healthcare and medical procedures, research and development, entertainment and arts, food and beverage industry, space exploration, logistics and e-commerce, education and training. Overall, I personally believe that why myself would be interested in sexist robotics, that would be outsourcing some of the tasks, and perhaps overall, since this week we're on the topic of hiring people, I'd rather have 20 of those robots instead of perhaps hiring people and employing people if possible. But see what I could do with this kind of area, perhaps. But overall, I'd rather have more of those robots who perhaps can perform similar tasks instead of hiring people. I have published a book. The name of the book is Game Strategy for anyone who's interested in starting your own business. You can find a lot of very important information of how to do it within the book. I have done, or definitely recommend everyone to do a lot of research before you start business to have understanding of what you can expect and what you you would need to prepare for. Overall, in the book, I'm sharing a lot of information, some of the basic information, as well as very advanced information that everyone should know of. Overall, I wish a lot of people would read it. You can find this book in the description below, as well as on my company's website. A lot of top retailers are distributing this book as well. Thank you. For anyone who is interested, perhaps, of building some of those six-axis robots, or already doing that, feel free to reach out to me. Definitely gonna be launching one project with that, hopefully in the near future, if I won't gonna be stuck in other perhaps different tasks. Either way, if you do that already, there are a lot of examples already that you can take a look at. Some of the German companies, Scandinavian companies, as well as there was one company in Texas who launched very interesting projects. I'm going to do full research work on the six axis robots a little bit later, but either way, thanks for watching and see you next one.